Most developers think they know binary search until they are asked to find a boundary or handle a rotated array. In this video, we are closing the gap between knowing the theory and writing bug-free code. By the end, you'll master 5 essential problems that define 90% of search interviews. Without a repeatable framework, you're just guessing at boundary conditions. Failing to handle these edge cases doesn't just lose you an interview, it creates silent bugs in production. We'll start with the classic search, but quickly move to a problem where the data isn't even sorted. The core of binary search is simple: look at the middle. If it's not your target, throw away half the array. But here is a micro-commitment for you. Why do we use left equals right instead of left right? Think about it, because getting this wrong is the #1 cause of missing targets. Here's the standard implementation. Notice how we strictly adjust the boundaries. We'll see in the next chapter why this simple logic fails completely when you have duplicate numbers, a favorite trick of Google interviewers. In the real world, data is messy. If an array has 10 sevens, a standard binary search might give you any of them. To find the first or last index, we have to modify our logic to keep searching even after we find a match. This is a common pattern in big tech interviews. By using a Boolean flag, we can reuse our logic to squeeze the search space toward the edge. Notice that we don't stop when we find the target, we record it and keep going. But what if the array isn't actually sorted in a straight line? That's the pivot problem. Imagine a sorted array that was cut and swapped. It's technically unsorted, but it contains sorted subsections. The trick? At any given midpoint, at least one side, left or right, must be perfectly sorted. We use that sorted side as our anchor. This looks complex, but it's just binary search with a sorted check precondition. Now, here's a variable reward. Did you know you can use binary search on an array that is completely unsorted? It sounds impossible, but we'll prove it with the peak element problem next. To find a peak, an element larger than its neighbors, we don't need a sorted list. We just need to follow the upward slope. If the element to your right is bigger, a peak must exist in that direction because the array eventually drops off. This is the monotonic property in action. Notice we use left, right here. This is because we are narrowing down to a single point rather than searching for a specific value. It's elegant, fast, and highly efficient. But wait, how do we bring all these patterns together for your next interview? We've covered the 4 pillars of binary search. You now know how to find exact values, handle duplicate boundaries, navigate rotated arrays, and even find peaks in unsorted data. These are the exact tools you need to avoid those painful off-by-1 errors. Remember, binary search isn't just a function, it's a way of thinking about halving search spaces. Whenever you see a sorted array, or a need for high efficiency, think O, log n. If you don't practice these problems right now, you'll forget the nuances by your next interview. Click the link in the description for our binary search cheat sheet. Subscribe to Code Assist Pro, and don't miss our next deep dive on dynamic programming. Your career depends on it.